All right, section 6.3 is quantum numbers, orbitals, and probability patterns. One objective here, be able to state the relationship between the principal quantum number, which is n, the number of orbitals, and the maximum number of electrons in the principal energy level. All right, so we were talking in the last section about Schrodinger's equation, that big fancy equation, and it worked in almost every example. It worked really well. But, you know, it was really hard for scientists to kind of visualize what does that mean that electrons are running around in a wave. What exactly does that tell us? We don't, it's hard to visualize that or think about that. So another scientist named Max Born used these equations and used them to find the probability. So he says, hey, this is the likelihood of where the electron is going to be. We think it's going to be in here, in this area. That's our probability of finding the electron. That's kind of what he used. Think of it as taking a snapshot of where the electron was every second. So if you did that, if you took that snapshot, you would get something like this, where, these darker areas in here, that kind of says, hey, that's where the electron is most of the time. And the lighter areas around the outside, out here, hey, it's not there very often, okay? So this kind of shows you the probability of where we're going to see it. And you can see the electron's more likely to be inside there than to be outside of there. And usually what they did was they said, hey, let's set that boundary at about 90%. So in other words, there is no real boundary for this. Just understand that. The electron can be anywhere. But for us, we set this idea that, hey, the electron is going to be inside of that sphere 90% of the time. They usually use that boundary of 90%. So they look at where the electron is, kind of plot those points, and then kind of find an area and say, hey, this is where it is 90% of the time. 10% of the time it's going to be outside of that, and we're not going to worry about what that's going to be like, but we're worried about what does it look like in the area where it is 90% of the time. And when you come up with that and you figure out where these electrons are, if you kind of solve Schrodinger's equations, you come up with 4 special numbers, which we call quantum numbers. And that's, we're not going to sit and solve those equations. In this particular chapter, we don't have any equations that we're really going to use. What you just need to know are some information about, this stuff. So in other words, we need to understand, what are they talking about when they're talking about the principal quantum number? What does that mean? But we're not worried about how we solve that and where we get it, except in general, but we're not going to solve those equations. But those 4 numbers will completely describe the energy that an electron has. And that energy is related to its wave and so on. Another scientist named Pauli came up with what's known as the Pauli exclusion principle. Says that no 2 electrons can have the same 4 quantum numbers. So in other words, every electron is identified differently in an atom with those quantum numbers. So with those 4 numbers, you can say, hey, I'm talking about that particular electron. That it's right here, it's in this place, it's in this level, in this sublevel, and so on. All right, so what do they mean? Well, the principal quantum number, when we were talking about the Bohr model, and we drew the little circles around the atom. So, here's my nucleus, and then I drew the circle. Okay, that first circle would be that first quantum number. That would be level 1. Okay, if I drew a second circle, that'd be level 2. Now remember, we've gone away from this planetary model. We're in the idea of these clouds and so on. But we're still talking about the principal number, and that's n. And you can kind of relate it back to these circles, so a third circle, hey, that'd be level 3. That'd be n equals 3 then if I was talking about some electron that's out there. So these principal numbers, use n. So whenever you see them talk about n now, they're talking about that principal quantum number. And, that could theoretically go on to, any number of the elements that we know right now. The quantum number goes up, the highest is 7. And then, Nothing goes beyond that because we would need more elements on the periodic table to describe those. They are positive integers, so there's going to be 1, 2, 3, 4, 5, 6, 7. That's really all they are. And it just means the main energy level. So like I said, it's like, just think of it, kind of relate it back to that Bohr model of the atom. It's that first ring, second ring, third ring. Although now it's a much more complicated thing than just a ring. But the ring idea, the Bohr idea, kind of helps you kind of simplify it, I guess, a little bit. In each principal energy level, there are also sublevels. And there are as many sublevels as whatever the level number is. So in other words, if I am in level n equals 1, there is one sublevel. If I am in level n equals 2, I have two sublevels. And that's all it is. Principal energy level 7 would have 7 sublevels, although we don't fill more than 4. We never get that far in that, in those atoms. We just don't have that many atoms on the periodic table yet. The total maximum number of electrons that you can have in your level is using this equation 2n squared. So if I'm talking about level 1, well, what's 2 times 1 squared? 1 squared is 1, times 2 is 2. So in the first level, I can only have 2 electrons. If I'm in the second level, it's 2 times principal level n, 2 squared. 2 squared is 4, so 2 times 4 is 8. Third level, 2 times 3 squared equals, 3 times 3 squared is 9, times 2, 18. So this tells me, and this is important, guys, write this down if you don't have this in your notes already, put this in your notes, to figure out how many electrons you can have in each level, you take 2n squared. Back in freshman science, you probably talked about, hey, the first level, you can have 2 electrons, 8, 18, 32, so on. This is how you get that number. This is where this number comes from. It comes from taking the principal quantum number, squaring it, doubling it. That's how many electrons you can have in that level. Well, we were just talking about the different levels that there were, and I said, like, in level 1, there's one sublevel. And they label the sublevels with letters. And there's no real, at least at the beginning here, there's no real organization to what these letters are. So the first level is S, sublevel is S. So in energy level 1, so in n equals 1, you have sublevel S. And that can hold 2 electrons. Okay. In the second level, you have an S and a P sublevel. Okay. So we said, okay, so energy level 2. Remember now, 2 squared is 4 times 2 gives me, so I can have 8 electrons in this level. I could have 2 in this, remember? So I've got an S. Well, that can hold 2 electrons. I have a P sublevel. P sublevel can hold 6 electrons. 2 and 6 are 8 that we had here. In the third level, we said, hey, you can have 18. Well, you've got S, P, and D. S can hold 2, P 6, and you can probably figure this out. D can hold 10. Now, there's no, it's fairly simple if you look at it. We're always adding 4, 2, 6, 10. So you can probably tell me in that next level how many can F have. If you add 4, it would have 14. So in this level, you got 2, you got 6, you got 10, you got 14. So altogether, you got your 32 that you're talking about. It's important that you know this stuff. You need to understand in the first level, how many sublevels are there? There's 1. That sublevel is S. Then the next one is S and P in level 2. And 3, it's S, P, and D. 4, it's S, P, D, and F. Now, theoretically, in 5, it could be S, P, D, F, and then G. But once again, these levels in black here, we don't really have any electrons in. We don't have enough atoms on the periodic table to actually fill those up. So we never get that far. But theoretically, it could be there. And so in this level, you could theoretically have 50 electrons if you went to that G sublevel. So there could be a possible 5 sublevels in the 5th level, but once again, that'd be an atom that would have over 100 some electrons, and we don't have that one. We haven't discovered it or created it or whatever yet. Okay, so we've talked about sublevels, or we talked about level. Okay, so that's N. We talked about our sublevels. Okay, and now we're going to talk about orbitals. And orbitals are where the electrons are located, where they are, where the electrons are flying around at, okay? And the number of orbitals is equal to the square of the principal quantum number. Okay, so let's see. N squared is what they're talking about. If we're in level 1, 1 squared means, hey, I got 1 orbital. Okay? If I'm in level 2, I have 4 orbitals. Alright, so let's see. Level 1 had a sublevel S. S, therefore, has 1 orbital. Level 2 had S and P. We know S has 1 orbital. We know there's a total of 4. So this has 1. Therefore, P has 3 sublevels. Now, I have kind of a way that I usually kind of try to help people out with this thing. Think about if, and we'll get into this a lot more in the next chapter, but let's say that we're talking about a hotel, because most of you can relate to that. Okay, if we're talking about a hotel, on the first floor, we've got the first floor. That's my N. N equals 1. And in that floor, I have 1 room, S. So we call this the S room. Okay, so this is S. And in that 1 room is 1 bed. We call that an orbital. Okay? And that can hold 2 electrons, by the way. So this bed can hold 2, just like a normal, queen size, king size bed you go to in a motel. Okay, so you're on the first floor, you're in the room, the super cheap room, okay, and you're in that 1 bed. If you're on the second floor, hey, you've got 2 rooms. Okay? Got 2 rooms. And 1 is the S room, 1 is the P room. Pretty nice. It's a pretty nice room. This room has 1 bed. This room it's a bigger room. It's got 3 beds. Beds are the orbitals. Okay? So, on the second floor of this hotel, there are 2 rooms, an S room and a P room. The S room has 1 bed, or 1 orbital. P room has 3 beds, or 3 orbitals, and each one can have 2 electrons in it. So you can see, hey, look, 2 electrons, 1 squared, well, let me go back. Okay, if I'm talking about orbitals, we said it's 1 squared, that's 1 bed. Here I'm talking about orbitals, it's 2 squared, or 4. There's 4 beds. See, 1, 2, 3, 4. Okay? So try to relate that to something a little easier and think of the N as the floor, sublevel as the room, and orbitals as the beds. Okay? So it's not very complicated if you put it down in those simple terms. Okay, so getting back, kind of reviewing. S sublevel, you got 1 orbital. In that S room, you got 1 bed. P sublevel, you got 3 orbitals. Okay, bigger room, 3 beds. D sublevel, 5 orbitals. Big room. Okay, 5 beds in this room. That's what they're talking about. 5 orbitals, 5 beds. Each bed holds 2 people. Each orbital holds 2 electrons. And in the F sublevel, 7 orbitals. Really big room. 7 beds. Okay? So, in that F sublevel, 7 orbitals. In the F room, 7 beds. 2 people in each bed, 2 electrons each orbital. Make sense? And of course, they don't look just always normal. They start out pretty normal, but then they don't get there. So we were talking about probability patterns. If we were plotting the points, and this, we all would kind of think, hey, it should look like a sphere. That makes perfect sense to me because that's what we've been shown. But we've been shown that because that's easiest. Okay, so if you're in that's the S. This is the S sublevel. Looks like that. Looks like a sphere. So if you're in that first floor, first level, you have a small sphere around the nucleus. Hey, if you're in the second level, that sphere is a little bit bigger, okay? But still sphere, that S sublevel in the second level. Remember, second level can have S and P. Well, what's P look like? P has these dumbbell-shaped things that you see here. A lot of times you see them, and they kind of make them look like that, okay? It has these dumbbell-type shapes around here, and there's 3 of these. Remember we talked about in the P sublevel that there were 3 orbitals. These are the orbitals. This is what they look like. This is the probability pattern. In other words, we sat there plotting points where we knew the electron was till we got a shape. Okay? This is the D sublevel. And notice that they're starting to get kind of weird. We've got like kind of double dumbbell things. And then we got some weird thing right here. Looks like a dumbbell with a donut, And remember, all this stuff's going around one nucleus. So these kind of, you've got all of these things in there. You've got the S, you've got the P, you got the D. And then when you get to the F, they get really weird. These guys down here look pretty weird. 7 orbitals, 7 rooms, or 7 beds rather. 7 beds there, 7 orbitals. Each of these things, there's 2 electrons in there. There's 2 electrons there, or 2 electrons there. Each of these things that they're showing you can hold 2 electrons. Okay? If this stuff doesn't make sense, you need to ask questions about this because it's important. This chapter doesn't have a lot of problems. You're not going to be doing a lot of equations, but there's a lot of concepts that are new and unique, and you need to understand those. If you got some questions, these 2 videos, and these are in your book, these are links from your book, these show about the sublevels and stuff. So if you want to see like the S's and P's and kind of shows you the shapes a little bit and how they kind of fit together, at least one of those videos showed kind of how they fit together and stuff. Pretty good videos, not very long, 2-3 minutes, I think, that you can watch those and tell you a little bit more about it. And there you have it.